chapter, Light Reflection and Refraction. Introduction. We see a variety of objects in the world around us. However, we are unable to see anything in a dark room. On lighting up the room, things become visible to us. But what makes this thing visible? During the day, the sunlight helps us to see objects, and objects reflects the light that falls on it. This reflected light, when received by our eyes, enables us to see things. We are able to see through a transparent medium as light is transmitted through it. There are a number of common wonderful phenomena associated with light, such as image formation by mirrors, the twinkling of stars, the beautiful colors of a rainbow, bending of light by a medium, and so on. A study of the properties of light helps us to explore them. By observing the common optical phenomena around us, we may conclude that light seems to travel in a straight line. The fact that a small source of light casts a sharp shadow of an opaque object points to the straight line path of the light, usually indicated as a ray of light. Let's learn about something new. Do you know if an opaque object on the path of a light becomes very small, light has a tendency to bend around it and not walk in a straight line. This effect is known as the diffraction of light. Then the straight line treatment of optics using rays fails. To explain phenomena such as diffraction, light is thought of as a wave, the details of which we will study in higher classes. Again, at the beginning of the 20th century, it became known that the wave theory of light often becomes inadequate for treatment of the interaction of light with matter, and light often behaves somewhat like a stream of particles. This confusion about the true nature of light continued for some years till a modern quantum theory of light emerged, in which light is neither a wave nor a particle. The new theory reconciles the particle properties of light with the wave nature. Moving further, let's study about the reflection of light. We are already familiar with the laws of reflection of light. These laws are: the angle of incidence is equal to the angle of reflection. The incident ray, the normal to the mirror at the point of incidence, and the reflected ray all lie in the same plane. These laws of reflection are applicable to all types of reflecting surfaces, including spherical surfaces. We are familiar with the formation of image by a plane mirror. Then, what are the properties of the image? Image formed by a plane mirror is always virtual and irregular. The size of the image is equal to that of the object. The image formed is as far behind the mirror as the object is in front of it. Further, the image is laterally inverted. How would the image be when the reflecting surfaces are curved? Let's talk about it in